All right, so the second thing we talked about today had to do with discovering area formulas for different polygons. Now, what I have is we cut out 3 different rectangles. Now, some have some other lines, and that's okay because we're going to do some other things with them. But my 3 rectangles are all congruent, meaning they're all the same size, same shape, and they all have equivalent area. So if I find the area of one of the rectangles, it's going to be the same as the area of any other of my rectangles. And we've known about rectangles and finding the area, some of us since 2nd grade, some since 3rd grade, and for sure you got a lot of practice with it in 4th grade. And so some of the things that I know about my rectangle, well, I know that this angle here is a right angle, or a 90-degree angle. And let me go ahead and put my name. So this shape is the rectangle. And I know, as we've learned about by rectangles all through elementary school, area is simply length times width. So if I find my length times my width, that is my area. And it's that way from 2nd grade, 3rd grade, 4th grade, and 5th grade. But what happens in 6th grade once you get to junior high? Now if you look at your 5th grade star reference chart, it does say this formula, or it gives you another option. 6th grade, we say, oh, you know what? Yeah, length times width doesn't cut it anymore. Length times width is great. You learned it because it works really good with all rectangles, including squares. But it does not work with these other shapes. With these other shapes, we have to look at it a little bit differently. And so we have to look at it as area now equals base times height. And so the base of my rectangle is this part down here. And the height is literally, it's the height from the floor to the top, how tall this rectangle is. And you might be thinking to yourself, well, what's the difference? It's the same thing, right? Length times width, base times height. And for the rectangle, yes, it absolutely is the same thing. But in the other shapes that we're about to look at, that's where it differs, and that's where base times height becomes really important. But for my rectangle, I didn't really learn anything new necessarily, just I'm looking at it with different names. And one thing that I've done is, if you can see, the base, I went ahead and drew it as blue and the height as orange. So I'm going to do that on all of these. You don't necessarily have to, but I'm going to do it just so we can keep track of these parts as we move through all of the different polygons. So the next one that I want to look at, I'm going to set this one aside, is this rectangle here with the one little line going through it. Now because this is a rectangle, I do have some information that I know about it. So I know that that's a 90-degree angle. I know that that is still my base. I know that this is still my height. And I know that my area is simply my base times my height. So I got some good information, some things that didn't really change. And so let's kind of take a look at that for just a second. And so I went ahead and colored the base and the height, same as before, so we can see what that looks like. Now what I'm going to want you to do is you're going to take your scissors and we're going to cut along this other small little line. Couple of important things to note: that my area didn't change. So even though I cut that, my area of this rectangle is still the same as my area of this rectangle. They're still exactly the same. My area, if I rotate it this way, does it change? No, area is still the same. If I turn it diagonal, does it change? No, my area is always the same, because my area is the amount of paper that it took to make this shape, right? The inside of it. The amount of stuff inside is my area. So my area didn't change. If I were to take this piece and put it up here, has my area changed? No, it has not. My area is still exactly the same. If I put this down at the bottom, has my area changed? No, my area is exactly the same. But if I move it over here to this side, My area still has not changed, but we can see we've made a new shape. And hopefully you can see that we have made a parallelogram. So my area has not changed. So let me move the camera here so we can see. So there's my parallelogram. I know we're working at an angle here, so it's kind of weird. But what I've made is a parallelogram. And so we see that this diagonal here is parallel to that one, and my top and bottom are also parallel. So I have made a parallelogram. Well, my base has not changed. My base is still that blue thing. My height still is perpendicular to my base. So when you go to the doctor and the doctor takes your height, the doctor doesn't tell you to stand slanted or leaning. They tell you to stand up straight and tall. But when you stand up straight and tall, your body makes a perpendicular line with regard to the floor. So you're perpendicular to the floor. You make that 90-degree angle. Same thing, my height of all of my polygons has to be perpendicular to that base. So there's my height. So the height is never this slanty thing over here. My height is always that perpendicular line with regards to that base. And so my new shape is called the parallelogram. But my formula for the area is exactly the same. And in fact, my rectangle is a parallelogram. So that's why my formula still works. Because rectangle is a parallelogram, base times height, base times height. So even though you've known this about the rectangle, really and truly you've known it about the parallelogram, you just didn't know that you knew it. So now we're going to look at this third rectangle, and we still have our base, we still have our height, that hasn't changed. And then this angle here is still a 90-degree angle. It's still a right angle. And so nothing has really changed. If I wanted to find the area of this rectangle, it's still area equals base times height, with my base being here in blue, my height being in orange. So that still hasn't changed. Area is my base multiplied by my height. Now, what we're going to do is we're going to cut along that diagonal. And when I cut along that diagonal, I'm going to create a triangle. So I'm going to go ahead and cut. And so my area is still the same as my previous rectangle. Like it's exactly the same. So base times height, nothing has really changed, right? So my first rectangle that I started with, my area is still the same. But if I remove half of it, what I'm left with is I'm left with this triangle. And so my triangle is no longer just area equals base times height, because I no longer have that same rectangle. In fact, I only have half of the rectangle. So I had the entire rectangle, took away half of it, and if I have half of the rectangle, I have half base times height. So my area formula for a triangle is 1/2 base times height. And it's actually true that any rectangle, if you double it and then rotate it around or flip it over, so if you make a copy of any triangle and then rearrange it, that triangle you'll find is actually half of a parallelogram. So all triangles are actually half parallelogram. Parallelogram is half, or is area equals base times height. So if all my parallelograms is base times height, all triangles are going to be half of a parallelogram. So my area formula for any triangle is 1/2 base times height. And the important thing is my height has to be perpendicular to my base. So if my triangle, for example, looked like this, then I wanted to take a height, I would have to do a straight line down perpendicular to my base. And so if I did that, then that would now be my height. But what I could do is any right triangle, if I know I have a right triangle, I can just rotate my triangle around, and then now I know that this over here can be my height and that can be my base. So just kind of something, a side note. Now we did some examples of that and I told some stories that go along with that in class, but all you need to know is that my height of any triangle has to be perpendicular to the base, and in this case it is. We're going to look at one more polygon to finish this out. So now that I'm an expert at the triangle, so here I have my last triangle, and I have my base in blue, I have my height in orange, and I know that my base and my height are perpendicular from one another, meaning it makes a right angle. And so here on this triangle, so it's perpendicular, so my base and my height, now I see that I have this line here, so I know I'm going to end up cutting that. But it's important to know that my base is not just this piece. My base is not just this piece, but my base, in fact, is the whole thing. It's this piece of the base plus this piece of the base. And I know I'm going to multiply that times my height. I also know, since I have a triangle, my area is actually 1/2 my base plus times my height. So area is 1/2 base times height. But before I do anything else, I'm going to go ahead and cut along this line. And so when I cut along that line, I have my triangle, but I'm going to rotate this piece around. And when I rotate that piece around and set it up there, I find that I actually now have a trapezoid. And we said in our trapezoid, when we define a trapezoid, is or quadrilateral rather. It's a quadrilateral that has one and only one pair of parallel sides. And we also said that those parallel sides are known as the bases. And so there I have my parallel sides in blue, and that's my base. Now it doesn't necessarily matter which one you call base 1 and base 2. If you want the top one to be base 1, that's fine. If you want the top one to be base 2, that's fine. It doesn't really make a difference. And why it doesn't make a difference, we'll see in a second. But I know my area formula is going to be 1/2 base times height, but since my base is in two pieces, base piece 1 plus base piece 2, all of that times my height. And so there we go. So 1/2 base times height. I just have to remember I need both pieces of my base. And so we'll go ahead and put a name on this shape, and then we'll be able to finish it off. So this is my trapezoid. Trapezoid, again, is based off my triangle, and it's 1/2 base times height. I just have to remember to get both pieces of that base. And the reason it doesn't matter is because my addition part is what I have to do first. So it's in parentheses. I have to do that first. And addition is commutative, meaning 2 plus 3 is the same as 3 plus 2. It's the same either direction. So it doesn't matter as long as I get this as the base, that as the base, add them together, and then multiply that times the height and take 1/2 of that. So you're going to glue all this in your notebook. I'll show you what that looked like in mine. And then after that, we will look at the very last thing that we're going to do. So in my book of knowledge, so here's my rectangle page. And so it was right after the triangle, so it was my page 119. Next, I did my parallelogram, then the triangle, and then last, the trapezoid. So hopefully that helped. You're going to go ahead and put those in your book of knowledge the same way.